slide. My thumb there just itches. So
we are now recording.
Yeah. So now back to work. It's end-to-end encryption for conference calls in WebRTC. Use case for WebRTC and me. So
okay, this is Imad. So yeah, I'm gonna talk briefly about end-to-end encryption for conference call. This is one use case for WebRTC and VAPIs discussed yesterday briefly by Bernard.
We did a scribe.
Oh, sorry.
Always forget. Do we have a willing victim, or should we just evict one? Varun, can you do it?
Sure.
Okay. We have a scribe.
Okay.
Yep, go on.
So yeah, this was briefly mentioned yesterday by Bernard and earlier today by Peter. So yeah, this should be quick. I know this was discussed like last June in face-to-face and over the mail thread. So my goal is to revive this conversation back and focus on a simple use case, hopefully make some progress. So I'm going to focus on fully trusted web application. So I remember from the mailing thread that there is 3 use cases like fully trusted web application, partially trusted, and not trusted. So I think the easiest one to focus on is fully trusted web application, but not trusted SFUs. So the web application will have access to the keys, JavaScript will have access to the keys. The SFUs can see the metadata, but not the contents. The contents will be end-to-end encrypted. The decryption itself will be done by the application, by the JavaScript, and only focus on audio and video, no text. Next slide, please. So what we're going to use is basically frame encryption. So we're going to use 2 layers of encryption. What's already happening today was at packet level using SR2B. This would be between the clients and the SFUs, which is outer encryption. And the inner encryption will be at the frame level, not at the packet level. So we basically encrypt the entire frame before packetization, and then attach the extra MAC and IV, and then packetize it, and then send it over the network. So this is different from what we have today, for example, in Burk, which double encrypt at the packet level. This improves the bandwidth because the extra MAC and IV is per frame, not per packet. Very, very similar to implement, and it's also not RTP specific, so we can use it for future protocols, i.e. QUAC. I'm not going to discuss the encryption schema or protocols details. It will be discussed separately in ITF in Prague 104. Next slide. Oh, this is too old. Yeah, I have much updated slide. But anyway, hey, Harry, is there any way to open the updated one, the latest one?
Let me see. Did you mail a link to me?
Yeah, I sent the mail over Hangouts to you.
Let me see. Where's the... Okay.
Yeah, the cat is much happier in the updated one. I'm just kidding.
Copy link address. Sorry, wrong buffer.
Yay, much more complex.
Al, could you post that link into IRC?
Oh. And someone who is both on the Hangout and the IRC do that? I haven't logged into IRC this day.
Okay.
We'll have to make sure that
fast
minutes
forward.
show the right versions of all the slides. So.
Okay, here is the angry cat again. So basically the idea is there are 2 clients, A and B. They want to send this awesome cat picture. So there are multiple key exchange here. On the left, there are secure key exchange out of band between client A and client B. This is for end-to-end encryption. But there is still the typical DTLS handshake between the client and SFUs for the hop-by-hop encryption. So what happened is taking the encoded frame with the metadata, encrypt the frame, but not the metadata, and then feed it into the regular WebRTC flow with packetization into smaller packets, encrypt so the gray squares are the end-to-end encrypted, then feed it to the SRTB, which is the black hop by hop. Then this packets will go through SFUs, decrypt the outer encryption using SRTB, regenerate the format. It does not see the media, do some SFU's magic, then it select forward to the next client, which is re-encrypt again using the SFU's, using the SRTB. And then the final client P will first decrypt the outer layer, construct the encrypted frame, then decrypt the frame using the end-to-end encryption keys. Next slide, please. So what do we need to change here? So basically, this is the typical WebRTC flow. What do we need to inject is the bold squares at the bottom, which is between the encoder and packetization. So between the encoder and packetization, we'll insert encryptor, and between the packetization and decoder, we'll insert decryptor. Next slide, please. So basically, we need two interfaces: frame encryptor with simple function encrypt that takes the media type, either audio or video. The source is SRC, the frame, and some additional data. In this case, would be the metadata. And similar for frame decryptor. And we are going to send these interfaces. As the app, we're going to set them like the implementation in RTB sender and RTB receiver. Next slide. Another proposal, as Peter mentioned, we could actually make it more generic, not specific for end-to-end encryption, but just general interface that like process the encoded media before sending it and process the encoded frame after receiving it. So in this case, we'll have like process outgoing frame processor and incoming frame processor, and just two simple process function, and we can just set them using RTB sender, RTB receiver. Yes, two simple questions. Do people think this is a good idea, like just focus in? I see someone raising his hand.
Giri.
So I'd asked this morning about the attack. Let's assume that we're worried about vulnerability in media servers, right, which have to actually break the encryption before forwarding on. If you're encrypting the frames at the application layer, would a media gateway be prohibited from doing any post-processing, such as video compositing and such? Is that
yeah, there is no mixing here. So it's basically SFE model. So it can modify the metadata if we want to, but not the content itself. So to not be able, so the SFE will not be able to see the media itself.
Okay. You leave audio unaffected though, so a media gateway would still be able to mix and do the standard things with the audio streams.
Using like virtual SRCs.
No. Okay, so this is basic. Okay, so this basic.
Yeah.
Okay, so right, so this is unusable.
But you can, SFU, for example, if you want to select like the top 3 audio, you can prevent forwarding the lower volume because the volume will be in the metadata. So the SFU can access to the metadata and see, okay, this is a non-speaker person, so you can forward them. So you can do such a thing, but not modifying the content itself.
It could probably also do frame winnowing, right?
Same what?
Temporal scalability.
Yes, for scalability, yes.
Okay, so I guess this so this goes back to my question in the morning. So what exactly at the transport layer security, whether it be DTLS or the various modes of supporting quick, that do you think are are vulnerable that makes this necessary? Yeah, but the media server, like I said, the media server is terminating the connection because it's doing something. Yeah, it is. It is terminated, but I think it's like I said. Yeah.
Can you guys talk to the microphone?
Yeah. Okay. So.
Giri, that's about you. You're too far. You are too far from the microphone to be heard.
All right, I'll try it again.
It's loose, so you can just drag it towards it.
Go. So the idea behind if I understand him correctly, the idea is, let's say you have an application that uses a third-party platform as a service to provide an SFU to relay, right? So the only thing that the SFU does is looking at the header possibly clone the packet to send to multiple people, but there is no real media processing. You can do the copying and everything if you use the frame marking RTP header extension or dropping frame in SVC and so on, without touching the media at all. So in the case where there is no media processing, which is the scope of the discussion, SFU with relay only, possibly SVC support, if you do not trust that media server that was provided by a third party, then the security provided by WebRTC initially with the TLS SRTP is not sufficient. So, hence the end-to-end encryption. You have a secondary, well, you have a third key pairs that is only between Alice and Bob. The media server doesn't have access to it. So when it terminates the DTLS SRTP, both the DTLS and the RTP, it doesn't have access to a full RTP packet. He has access to an RTP packet whose payload has been encrypted. Is that correct, Emad?
Yes, correct.
Yeah. So to summarize, this is a middle box that's acting purely as a relay. It has no need to do any kind of processing.
No.
It has no reason to access the media.
No.
That's
And
correct.
it's a box that you don't trust.
Yes, exactly.
That's
You
correct.
made it. Okay.
No
So
mixing.
only the two endpoints of the call or the group call can access the media contents.
Okay, but that's also the other thing too. The two endpoints, which in this case is not necessarily the end user, but the applications, are making a connection on behalf of the end user to a gateway, to a relay that they don't trust.
Correct.
Correct.
Okay. Okay, thank you.
So I have some questions about the API changes. I'm not quite understanding. Is this WebIDL? Are these browser objects?
This is my own language.
Okay.
Mixed between C++ and JavaScript. Yeah.
So is the goal to do encryption, decryption in JavaScript?
Yes.
Okay. I think in that case, we should probably not try to do that on the main thread. So I would question that. And we've talked about other.
And not JS, because it will trigger GC, and then in a real-time pipeline it might have difficulties as well.
Well, JS could mean WASM.
Yeah, that might work. One thing is, so you're targeting a specific use case, and that's okay. It's always good to start there. But you also need to consider the other use cases, so that the API that you're designing will work, or there will be ways to handle the other case in the future. One potential issue is if you have the keys available or generated by JS, observable by JS, then it makes it really hard. So the more we can isolate the API from that problem, the better. Like if there's just one specific point where we are doing that right now because that's the only way, maybe that's fine. But it should be very it should be just one point, so that we can actually try to have better solutions. Hopefully, this way we can reuse the other parts when we try to tackle the next big thing, which is probably bigger in terms of use cases.
Sure, that's fair enough. This means, or what you're suggesting, can go with more general API, something like this, and someone can use this APIs for encryption. Some other people can use it for some other stuff.
This might actually be a prime example for the streams for what WG streams as presented by Peter for RTP.
Yeah, so in my time slot next, one of my slides actually shows how you could use what WG streams on senders and receivers to do the same thing. And if you combine that with the worklet version of transform streams, you could potentially do the encrypt and decrypt off the main thread, and also have it available for other processing purposes.
Get back on. So I don't, I don't know what the protocol is. I'll look for the IETF contribution. But are you assuming that that any private key material associated with the protocol and the handshake for setting up the encryption keys will be implemented and fully contained within the browser, or are you planning to rely on some sort of platform mechanism in order to make that work?
So as I mentioned in the very first slide, so it should be encryption, decryption will be as application, not in the browser itself. So we'll just provide this APIs to the application and can they inject their own implementation.
So the application will have to take care of it. It will take care of any handshake for negotiating a symmetric key. The application will control any private key material, for instance, related to any kind of cert that would be used. All right. Okay. So, there's well-known attacks on key material when you contain them in the application. So so this will only provide you security to a point. In other words. Okay.
So it's entirely possible that you could write encryption JavaScript that used crypto APIs to get rid of the key handling. But as far as I understand it, the proposal here is that we don't require any such thing. That we say that whether this does encryption or with XOR or ROT13 or whatever, that's entirely up to the application. Is that correct?
Yes, correct.
This one? That one.
Be possible to use it for other things as well?
Yeah, one use case, for example, if you want to store the frames, like something I can come up, but I'm not aware of like other use cases. We can just see what other people can do with have access to the encoded frame.
Yeah, I think it come up before about FEC and encrypted frames, and I'm curious if someone's actually thought about adding FEC on top of this and sending. Like you get the encrypted frames, and then the problem is when you have the media bridge in the middle, and if you do forward error correction, and if it's inside the encrypted part,
so FEC will happen hop by hop, so it has to happen after the encryption.
It'll happen after.
Yeah.
Okay, that's already been standardized somewhere, or
because we're in
standardized.
No, it's not standard somewhere.
No, I think because FlexFec made the assumption that it would be before encryption, and I don't know where we landed on that, even though I'm one of the co-authors of it.
If you don't know, then I'm sure I don't know.
I think the pendulum went back and forth so much on that I think the working group probably knows. But
so I believe all the FEC stuff happens at the packet level. So all the encryption here happens before packetization, just as a frame. So everything happened after should continue working as before.
So, sorry, I was just going to say that from considering the use case, I think it's fair. But as far as the API goes, it sounds like this is pretty much a transform stream. And then we've already decided that if we're going to do anything like this, it should be based on what WG streams.
So, yes and no, because there might be a decision to be made. Apparently, there's some work in the IETF, right? So, if there's an IETF solution, there's a decision to be made, which is should it be implemented in JavaScript or in the browser? Right. And since it's related to security, usually you do not want people to write their own crypto algorithm. So, do we want people to write their own perk implementation in JavaScript, and maybe it will fail, maybe it will be okay. I don't know how complex it will be. Or do we actually want to let the browser handle it? And if we let the browser handle it, the API is very different.
Right. Yeah, so short term, I agree that's a decision. I mean, long term, if we are considering a transform stream APIs, then, we can't really prevent JavaScript from.
Something we could do is expose a helper utility that exposes a transform stream that does it securely as part of the specification.
Right, specific transform stream that is per transform stream.
Right, that's a good point.
So,
but again, the API is different.
So we're talking about this behaves like a transform stream. And in the particular use case we have here, the transform stream is going to execute JavaScript, which is probably executing WASM. So other cases could do other things, including a standardized encryptor that could be implemented entirely within the browser. But I think that's not part of the proposal at this time.
I agree that if we design something, we should be able to tackle both the short term and the long term. And if we have a correct path between the two from migrating, then it's nice because some early adopters might rely on JavaScript and might succeed or might fail. We will see, but at least we might anticipate that we will have a long-term solution that we are sure will be working, even though it might be a lot of work and maybe we'll never get there if the short-term solution is good enough.
So it's a good point about perk. Are we making a decision implicitly about perk here, or?
No, we're not making a decision about perk. Period.
So to summarize, I think there are two things here. Like this, the generic APIs looks like transform stream, and the other thing is it like we implement the encryption as the application or as the browser? This depends basically on the IETF stuff, right?
Yeah, I will say with regard to encryption in the browser or in the application, we should think carefully about the security trade-offs there. I don't think we can say anything more than that.
So in Stockholm, we spoke already about opening a little bit the pipeline, right, to put arbitrary transform in there. This is just a variation of an arbitrary transform. It might be duplicating other stuff. Some people send media over WebSocket, like Zoom, right, instead of using WebRTC and so on. Is there any reason to actually reject the proposal? Because we might, in the future, do the same thing inside the browser. I understand security is a little bit sensitive, but if this is what the application want to do and it fits one of the design we have agreed to discuss previously, why rejecting it, right?
Yeah,
you're saying, let's not do it because we might do perk in the future. Well, that's the way I perceived it, so my perception was wrong.
I agree with Dr. Alex in the sense that we should add a mechanism for doing arbitrary transforms. And then if applications want to use that for end-to-end encryption, they can. And then later, if we feel that it's worth making something that's standardized in the IETF into the browser, because that will help people do it right or lower the barrier to entry or whatever, then we can also do that.
Yeah, I think I agree with that. It's you start with something that is very focused. It's very cheap because there's already something that we might be going to, and then there might be a longer term thing. I was not at all saying that we should refuse that proposal. I think we should consider it as a use case and as somehow as a goal, a direction, so that we create a model that will comply with that at some point. That will resolve most of the issues of this use case.
Is it not covered in Bernard's use case document?
It's covered as one line. I'm just here to describe it in more details. Yeah.
Okay.
Yeah. So what I'm hearing here as a conclusion of this this part is the working group would like to see this proposal fleshed out and based as closely on transport stream as possible. Transform stream.
Who's owning transform stream? Is it Bernard or someone else?
Transform streams are owned by the WebWG.
Yeah.
However, access to the encoded frames in order to transform them is covered by this working group. It's not something we have yet, but it is something I cover in my next. Yep.
That's the point I would like to make, is that this creates a requirement on exposing and new points in the pipeline, and that's a debate we need to have. Maybe we will agree, maybe we won't agree, but this is a use case that we should consider during that discussion.
Yes, that's it. That use case is a driver requirement for that particular one. So should we switch to Peter?
Sorry, just one last question, because I'm not familiar with the TPAC process. So what's next? Like, are we going to like discuss this on the mailing list? Like, how can we move forward from here?
We will take this to the mailing lists as in the first place seen as what we can flesh out in the use cases, and the second case to see if we can get a concrete proposal together.
But do we have consensus that we're going to include this use case, that we're adopting this use case? Because at the end of the face-to-face in Stockholm, it wasn't clear that we were. I think there would be progress if we were adopting that use case. Whether or not it's a specific,
okay, so
it's from the IETF version or a generic mechanism for processing or transforming encoded frames.
So I'd like to, let's consider just that issue. So what I'm hearing is that people want to. A number of people have said that they want to support this use case in WebRTC NV. So does anyone wish to speak against supporting this, including this use case in our WebRTC NV requirements?
Well, would it be fair to say that the use case is to have end-to-end encryption?
The use case is to make it possible to have an application do end-to-end encryption.
Well, that's the distinction, right? So,
yes, that's a very important distinction. And
I think we can agree with a broader use case at least.
Which one is broader?
So at the last face-to-face in Stockholm, there was confusion on whether we wanted a use case where we trusted the JavaScript application, but not the server, and versus not trusting either. And so this is, we trust the application, but not the server. And if that's the use case we're adopting or not, whether or not it involves an API that assumes IETF docs and built into the browser or not, like you're still trusting the JavaScript.
Yeah, I think as Ewan mentioned, I don't think we've fully had the discussion yet of if that requires exposing raw network data, I guess. And so I think I'd like to agree on that we should support end-to-end encryption. On the application part, maybe we could take it to the list so I get some time to confer with my folks.
You have a number of security guys in the company.
Yeah, did we make any progress?
Yeah, because otherwise we need to, speak about it at Prague, in Montreal, and yet we don't know where in Asia.
So I would like to say that we have adopted the end-to-end use case where we trust the application but not the relay as part of the requirements. That's a step forward.
Okay, good.
And Jan-Ivar, do you want to verify that on the list?
Yes, please.
Yep.
I mean, if this is really a subset of the broader use case of whether the application should be able to transform raw frames. Okay, I know you don't like it when I use the word raw, but frame data, then really once that should be the primary question to be answered, because after that, if the application wants to implement their own protocol end to end in order to encrypt, they have the capability to do that with what's available in the browser today.
That's a separate question, and I don't think we have consensus on that. But if we can at least have consensus that we're including one instance of that use case, at least we're making some progress. Yeah, I'm going to talk more about the second question, the one you're bringing up in my presentation.
Okay.
I have a specific proposal for how we should do it.
So the working group is still considering the generic access to encoded data use case. So with that, can we jump to Peter again?
Yeah.
I'll see if I can bring up the latest and greatest version of your slides.
Please, not the one from an hour ago.
You sent me a link half an hour ago. I'll try.
That's good enough. Yeah. Oh, you skipped ahead. Okay.
You sent me the link to the
So I'm talking about media over quick, but it's more like bring your own transport. So it could be media over other things too. So next slide. First thing I want to bring up is the fact that people are already doing it. For example, there are already people sending live media over HTTP over quick and putting it into MSE. And they're asking us for a better server push, basically. And they would like to use the quick transport to push chunks of media over that to push it into MSE. There are also people doing live media over SCTP data channels already and putting it into MSE. There are two examples there that recently had some details published. And I reached out to one of them, and their specific request was that they would like to switch from SCTP to Quick because of the pain of having SCTP on their server. The last is that people are already sending media over WebSockets, which is something was brought up earlier today. And they're not even using WebRTC at all. They're using WebAssembly to do the encode and decode for both audio and video. And I haven't talked to them, but my proposal would be that quick transport would be better than WebSocket. Assuming we didn't have the requirement for ICE and you could do it client server, at the very least you could avoid the head of line blocking and congestion control problems that WebSocket has. So next slide. You can already do all these things, although somewhat poorly. On the decode side, you can already use MSE, which is pretty good. And on the encode side, you can already use WebAssembly and either Web Audio or Canvas. This is what Zoom is doing. And on the web audio side, it's pretty good because audio encode and decode in WebAssembly is not too bad. But on the video side, video encode with WebAssembly is not so good. So basically, you can already do the things that I'm talking about today. I'm just talking about making it so that red box is not so red. And actually, all the boxes are more green. So next slide. And people are already planning on doing media over quick. I'm a member of the the second screen working group, and we're, as I mentioned earlier today, considering doing media over quick for streaming purposes. There's also a mailing list already in the IETF for talking about sort of next gen RT media, and someone's already proposed the idea of doing media over quick. The implementation of WebRTC that is widely used, libWebRTC, is adding support for media over quick. We have some slides in more detail about that later on. At the moment, it only supports mobile because there's no web API for this. And that the team working on that has already made an experimental mobile client to see how well this works. And the conclusion is that it works pretty well. But web support is a problem because there's nothing in the web that can do this. So, or not do it well, referring to my boxes previously. So I have some proposals for how to fix that. Next slide. There are two proposals. One is to adopt the quick transport, which we already have a spec for, but which is not adopted by the working group. And second is to add WebWG stream support to RTP sender and RTP receiver for encoded media, something we were just talking about. Next slide. So on the topic of adopting the quick transport, I'd like to point out that there's a lot of interest from outside the working group. So we could continue work outside of the working group, either, for example, in the ORTC community group or in an incubation group. There's already been people that have wanted to start an incubation group to make a version of WebSockets that runs over quick, basically covering the client server use case, but not the peer-to-peer use case, a version of quick transport essentially without the ICE transport underneath. And some people would even prefer it to be outside of our working group. The tag, for example, in the tag review mentioned that why is this in the RTC working group? This is more broad than RTC. So I feel that this is going to move forward one way or the other. The question is whether this working group wants to be a part of the work or not. So that's my first proposal. We can stop and talk about that before I move on to my second one.
Yeah, so Mozilla position is still that the quick spec is still basically doing TLS and HTML, and it's premature to send media over quick in a web spec.
So to be clear, I'm not proposing any web spec about media over quick. I'm proposing a quick transport for doing data over quick and a mechanism for transforming audio and video frames from RTP sender and receiver. I'll get to that in a sec. Those two combined could do media over quick, but there's no spec here about media over quick.
Okay, but yeah, I think that's the same thing, though. Right.
Well, that's like saying we're standardizing media over SCTP because there's an SCTP data channel, which is not the case.
Right, but I think the information we've gotten from the quick working group is that using it right now, they're focusing on TLS, HTTP, and not any other uses. Right.
Other people are going to use Quick for other things.
Sure,
but I don't think it's within the Quick's working in the ITF's Quick charter to think about media over Quick. I think there are people independently in the ITF which have thought about media over Quick. I'm one of the co-authors of a spec which talks about RTP over Quick. So there are people definitely thinking of it. It may be part of the Quick working group, or might be part of AVD core, or might be part of something else. That remains to be seen.
To put it another way, the current specifications for Quick allow transferring data. It's possible that there might be changes later to Quick that make it more useful for transferring data that contains video frames. But that doesn't mean that doesn't prevent anyone from using the current version of Quick for transporting video frames, whether or not the spec says anything about it. Not doing Quick because Quick hasn't admitted that it's useful for video frames. Well, it doesn't pass the smell test for me.
Well, I think in order to adopt a quick transport would be using Quick wholesale for this one purpose. My understanding was that that would rule out that might have some impacts on other uses of Quick potentially, and that we still consider it too early to know that.
What do you mean? What do you mean by impact in this case?
I think it was touched on in Stockholm. I don't know that our position has changed much.
No, I'm asking you, what do you mean by impact? Impact on operations, impact on network, impact on end systems, impact on standards?
Other uses of Quick, basically. Like if you have a Quick transport, I don't know that all the network concerns are covered. And that would be something that I think we should rely on the Quick working group to tell us how that should work.
I am not convinced, but
so the Quick is a congestion controlled protocol over UDP. So I'm assuming, and it has some security property. So from a networking perspective, I think if and when the Quick working group in the IETF ratifies it, and it's going to probably go into the IESG, and when it does, it can be used for anything. I guess the question here is, do we want to use it beyond the scope of whatever the Quick working group has delineated it for? I think if it's a congestion control protocol, we can use it for anything, given that HTTP was used for doing video streaming, which it was not initially destined to do. So Dash and HLS both use HTTP for video, which no one thought initially was a way to transport video. So not the same use case though, but it allows us to experiment beyond what's possible today.
I think I think Quick for transferring data sounds very interesting in and of itself. I think being able to transform frames sounds very interesting in and of themselves. I think being able to do swap up encoder decoder sounds very interesting on their own, and like you take all of these together, it sounds very, very interesting. I don't know details, but I mean I think this is interesting and it has potential.
So I have the second proposal for the streams part of it coming up. So I would appreciate if we can come to some conclusion here so I can move on to the second proposal.
I think what we said in Stockholm is that if we could proceed in a transport agnostic way, that would be probably a middle ground for now.
What do you mean by transport agnostic?
That we can consider all the other benefits that Henrik mentioned, strategies down the road, so that when Quick is ready, that might be one of the options.
Well, that's essentially the second half of the proposal 2 is transport agnostic. Okay. So there's a transport proposal here and a transport agnostic proposal here. But I want to know if this working group is going to adopt the Quick transport or not, because if it doesn't, we should proceed somewhere else.
So let's try a simple one. Who thinks that this working group should adopt the Quick Quick API document?
Well, I was instructed that if any attempt for consensus should be on the list.
That is noted. This is a straw poll for the information to see if there's any point in continuing. Who thinks that we should adopt this document? Who thinks that we should not adopt this document? Thank you. We will take this to the list.
Thanks. Next slide.
Harold, is the proposal narrowly for data for data channel, or is it for all media?
This is a proposal for adopting the Quick API document proposed by Peter. It does not say anything about what this API could be used for.
All right. Let's move on to proposal 2. Proposal 2 is about nothing to do with transport, just media. So the gist of it is that the RTP sender and RTP receiver can include a mix-in that has this on the sender side 2 new methods and on the receiver side 2 new methods. It allows you to read encoded frames from the sender and write encoded frames to the receiver, and then read feedback from the receiver, such as a keyframe request, and write the feedback into the sender. And if you go to the next slide, there's an example.
I have one question.
Yeah.
There's also local stats and local feed.
That's in the feedback.
That's in the feedback?
Yeah.
Oh, okay.
I included the stats in the feedback. Now, we could tweak that if we felt like a get stats on this was a better approach. Like this isn't the final say on what the...
To me, it would seem like maybe what Dom said made more sense. Like when you say read, can you go back one slide?
Sure.
Yeah, so you had read encoded frames. You would have read local stats or get stats or something similar there. Because when you say write feedback, I'm assuming that's coming from the far side and not the local.
Oh, yeah, you mean taking sender stats over to the receiver.
Oh, yeah.
Yeah, that's true.
I mean,
you would need to get stats for that.
I find the direction of the word write and read to be totally confusing on this slide. Sorry.
Okay, well, you can look at the comment. we can bike shed the names, but the gist of it is the encoded frames comes out of the sender. It's basically acting like an encoder, and you bring your own transport. You send it however you want, and then or you process it however you want. You can pull them out of the sender and stick them back in. I have a different slide for that a little bit later. And then on the receiver side, you can put the encoded frames in and treat it like a decoder.
Yeah, I just wanted to make a point that there might be stats on both sides, which might be local and remote.
Yeah,
you might be getting from remote.
You're right. And the way that you can handle this is that you can have the encoded frames coming out of the sender be either frames or stats. Yeah. And that's actually the way that I specified it. If you look at what goes in the readable stream there. Okay. It's just hard to fit all that on one slide.
Yeah, I do remember that from like the slides before, but just not seeing it here just spooked me.
Yeah, I was trying to simplify the slide. It's already complex enough, right? Yeah.
So what have you, since you're managing, the application's managing its own transport, what if it wants to actually do something different depending on the type of encoded stream, like an iframe or a p-frame? What would it, I mean,
whether it's a keyframe or not is in the frame that's given to you inside the readable stream when you call read encoded streams.
Okay, so it would have to peek inside the frame and then.
No. The thing you get, and it's on a future slide, is an object that has metadata on it, including if it's a keyframe or not. Right. So it's no binary thing you have to parse. It's like.
So I think specifically you could easily drop that frame if you did not want to send it for whatever reason.
Yeah. Just don't send it on your transport. Yeah.
So I'm also a little confused about the wording here, but I think my main objection here is that this adds, well, it's less about adding what WG streams to sender and receiver, but adding a way to get data out and into sender and receivers, right?
It's a way to get encoded frames out of the sender and into the receiver. Yes.
Right. So I'm not sure we should expose that on the main thread. That would be my
So this,
feedback.
If you go to the next slide and you look at the example, this entire thing can be off the main thread, assuming that the transform stream function call there is something that gives you a transform stream that can happen off the thread using any of the mechanisms that we thought could be possible. So the pipe through in the middle there, where it goes to either the serializer or the parser, would happen off the main thread. The only thing you do on the main thread is set it up.
Right, but in designing the API that way, we make it possible for JavaScript to easily do foolish things like that would end up doing it on the main thread.
What would happen on the main thread? I mean, if we did the transform stream with a worklet, you can't run anything on the main thread.
Right. I'm just saying maybe, for instance, if other approaches would be that to say these methods are only exposed on when in the worker, for example, that might have.
Oh, because you want to prevent people from
accidentally doing
that. I don't know if that's really worth it, because I've talked to several people about how important it is to them, the people that are using SCTP to put things into MSC, and they're doing it on the main thread, and they said it's not a problem for them. So even though we think it's a problem, and I totally agree that we should come up with a good solution for it, which is why I presented so much about it. There are people that think running on the main thread is fine for them. And so like telling them they can't do it is kind of weird.
Well, it might be fine for them, but it might not be fine for browsers who might have all other tabs, and people customers wondering, why are all my tabs slow? Because you have a tab and you forgot about that does all those things.
So I guess the question is it a foot gun that has any other purpose than shooting in your own foot, or is there real reasons why you wouldn't want to go off the main thread for doing processing of these frames?
If somebody wants to use it off the main thread, they can, and if they don't,
well, I mean, if it's just a foot gun, then
I don't think it's just a foot gun.
Okay,
I think some applications will want to do it on the main thread, and I think that's fine. But a lot of them will probably care about not having it on the main thread. So I think it's good to provide a way to do that.
I mean, I guess I'm with Yanivar that if we can push people towards the right thing, make it easier to do the right thing rather than the wrong thing, that's better. I don't know if that's up to forbidding it completely on the main thread, but there may be more we could do to avoid it being the default thing you do because you don't want to look into workers or whatever.
Yeah, I think if it's easy to use a transform stream off the main thread, and we're basing this off of what WG streams, and all the examples people read are like, here, get this transform stream and get this, and plug it. They see this line of code as the example, then the obvious path to take will end up being one where you are off the main thread. But having it like throw an exception because you didn't do it right,
Maybe I'm missing a piece, but I mean, the generic transfer stream with a uppercase T is pretty much just a JavaScript. I mean, it's a class, but it's a JavaScript construct that doesn't automatically make it exposes. It lets JavaScript write classes that act as transfer streams, but does not. It's still not a browser object that the browser could then move that information off main thread.
No, what I was saying is that if we have an implementation of transform streams off the main thread using a worklet or a worker or whatever we've talked about before, then it should be like 5 extra lines of code in order to get one of those instead of, not lines of code, it's like characters in the code, to get one of those instead of the classic on the main thread transform stream.
Right. So yeah, I think this is interesting. I think it's one of the options. I also believe that it's one of the lower priority items that when we sorted all the priorities, it sounded like this was on the lower of the list, at least from what Yuan mentioned. So I think it may be a little early to say one way or the other, but I'd like some time to look at it.
Okay. So then, is it worth making an extension spec for this? Just like we did for Quick, where then we can debate whether we actually adopt the extension spec or not, but we have something specific to look at, more specific than one or two slides.
So one of the problems with evaluating slideware has always been that there are lots of devils in lots of details, like Varun's mention of where do the stats go?
Right. Well, so the same happened with the quick transport, and we learned a lot from both writing the spec and implementing it, and we ended up in a much better place than the original slide. So I think we could do the same here. The question is if we should start that now.
So I'm again, I hear you about either you do it here or you do it elsewhere, but in neither case will you personally be free up any time to doing WebRTC 1.0 stuff by not talking to the WebRTC working group on this one. I mean, it's a question of, does starting this stuff now make anything else later or not?
Well, maybe another way of putting it is, are there other people interested in working on this spec?
So
now.
So personally, I think we're willing to contribute resources to this effort, and especially documenting it. And especially for this particular use case of both media over quick and quick bidirectional and unidirectional flows.
I think that the tricky problem is getting things off main thread. And we've heard a couple of proposals earlier. One of them was to, first bring data channel to workers and in an ORTC-like way, and then maybe other objects would follow that would only be accessible in workers. Maybe workers are fine with regard to garbage collection and video. Maybe it's not. Maybe the worklet way is better. I think there's a lot of experimentation needed to to know which approach is going to work better. And I worry that focusing on the API first might be pre-selecting one or the other.
So if we start an extension spec to allow access to encoded frames from the sender and receiver, would you be interested in contributing by figuring out how to properly make sure it's off the main thread?
I think personally I'm going to be busy with 1.0.
Well, hopefully he'll be done by the time we've got the extension spec going. All right. So anyone else interested in contributing?
So we have 2 expressions of interest so far.
Right.
Yeah, I have one resource working on that already, experimenting, but I think this is the stage where we are experimenting. There will be a meeting of the quick working group at the end of January in Tokyo, 2 days working group and 2 days hackathon, interoperability hackathon and things like that. So maybe that would be a good place to hack on that ID and on the WebRTC stacks. I understand that there is an existing implementation that is ORTC, but that is in the code of Chrome and WebRTC standalone as well. So we haven't started coding, but we were thinking about starting the experimentation there.
Right. So I would like to give some time to Anton, who has been working on code inside of libWebRTC for adding support for Quick. And I think it'd be useful for people to know about the progress he's made so that these kinds of things can move forward. So can you skip forward a few slides?
One more comment would be that I think what might be useful is to get feedback from the WhatWG stream group to see, because I know, for instance, Audio Worklets right now does not rely on readable streams at all to pass messages back and forth. And I know, so if they have thought about, so this use of transfer streams to offload to main thread and exactly how that will work is still a little of a new territory. So it'd be good to get feedback from them if that's an approach they sanction.
Yeah, definitely. I agree.
We already.
Next. Next. Stop this one, yes. So I've been working on integrating Quick in libWebRTC, and this is still highly experimental. Although we think we'll be successful, we have very successful prototypes working, and we are also actually already checking in code in libWebRTC, like the interface is checked in already. So I think, I mean, besides like why we're implementing Quick at all, if I think this work that we are doing, it will make it actually easier for the web applications and for the browsers, because the way we are integrating it, it will make easier for browsers to implement proposed APIs that Peter was talking about, if we decide to go with these APIs. And also, we think that for applications today, it's a pretty higher cost of doing both native and web apps. So if we have similar building blocks in libWebRTC and on the web, that will reduce the cost. So why we are so passionate about Quick for media? I think Peter maybe talked about it many times in the past, but I want to reiterate it because we started it not because of the web. We started it because we want Quick for the media. We think it's much simpler stack. If you're familiar with RTP, I don't think you will disagree. There are few interesting side benefits, like few RTTs to set up encryption, and we see many opportunities for quality improvements that we actually prototyped locally. We see opportunities for lower overhead, better retransmissions, and very easy to add extensions and features. Like, did you try to add extensions to RTP or implement, I don't know, improvements to retransmissions? Like, anything in RTP world is very hard. And also Quick for data channel and Quick for media, of course, we want to use the same path. So quickly, how we are doing it. Today, if you are familiar with libWebRTC, it's the code is very RTP
aware, even the media parts of the code. So we actually refactoring it so that between the transport part and encoders, there is this media interface layer, which is strikingly similar to Peter's proposal, which is like, here is your encoded frame, or so send encoded frame, receive encoded frame, and send me the key frame, and so on. And we are refactoring the code, so it will be like transport agnostic actually, so that we will re-implement the legacy RTP on the same interface, and in the future can have any transports. And I have a link in the bottom. You don't see it. You can look at the interfaces currently. We are also doing the data transport implementation for now, the data channel, sorry. For now, we will use existing data channel, the WebRTC, on the Quick, so that applications can migrate without any code changes. But in the long term, of course, we want to use something like Quick Transport that Peter was talking about, and then have the media through the same Quick Transport interface. So what is this media transport actually? What is this middle layer? What is it? So in our prototype implementation, it's this one Quick per frame. We define wire format and implement serialization, deserialization, and then send it to Quick. We use protobufs currently, which is like super easy for serialization or extensions. We have some extra retransmission control on top of Quick because we need some different audio and video implementations here. Adaptation and bandwidth allocation is an interesting topic because I think the long term we want to have this media transport pretty much tell encoders and what should be the bit rate or frame rate, etc. Right now, we keep the adaptation inside the stream, receive stream and send stream. Sorry, inside the send stream, but we will probably move it inside the transport later. And it is a pluggable component, so we think there is no need to standardize it. There could be default implementation, but I think it will really benefit if you don't standardize the wire format for frames. So we have some of the challenges. The congestion control was like one of the biggest issues for us. We found that existing Quick congestion control is not ready for real time. We did not give up, but we decided we should try to integrate congestion control from libWebRTC, which works well today with real time, and we will plug it into Quick. But the question is what to do next. Do we standardize it in Quick, or keep it as pluggable, or should we fix BBR? I think it will depend on our success. SDP is something that we kind of said, okay, we'll do it later, but it's an issue for us. So currently we assume that application would negotiate Quick Transport, but we should decide what to do forward. So one option is just not to use peer connection API for Quick, or I mean we can cheat, but cheating is not nice. So we can add, but we can also add Quick media transport option for SDP, but I think maybe we need to standardize the protocol itself if we make Quick like official part of peer connection. FVC is not currently supported by Quick. I think eventually it will be needed for a good quality media. And just general question: what is next for libWebRTC? Is it a peer connection model for native, or do you want to have building blocks? And current thinking is that, as I said in the beginning, it would be really nice to have some similarities between web and native, and to give more control to the apps. So, like media transport is one of these building blocks that we are proposing. There could be ICE, encoders, and so on.
So I have a clarification question. Leave it open for the application developer to choose if they want to send the media frame over a single quick transport, multiple quick transport, or
yes.
Streams.
Yes.
All right. Thank you.
Peter, did you have more slides? If there are no questions.
Yeah, I mean, FEC was supported in Quick at one time, and it was ripped off.
It was correct. Yes.
Yeah. So I mean, what what were the lessons learned from that? And, you know, like particularly if we're considering adapting FlexFec.
I think they did not consider real-time scenarios, and when we think how FEC should be implemented, should be very well aware of the media. Like for example, for audio and for video, it would be very different. And there is some feedback on RTT, like jitter buffer size. You want to take it into account. Do you know, Peter, what were the issues why FEC was not used for?
They removed it because they didn't see any benefit in measurable statistics when they had
The
it turned
reason
on.
for that was basically because you have only when you're sending packets inside a quick stream, the only time it would help you is during the tail loss, because that's but at that point you have so little data in your buffer that it was only at the tail end of that stream or channel that you would see that benefit. In our case, I guess it depends a lot on what type of strategy you're going to use to send your frames. Are you going to if you're going to send a group of pictures over a stream, or if you're going to send a single frame or a single packet, because that's totally up to you as an application developer to decide what you want to do. And the use of FEC is more with long-standing sessions. So if you're only going to send like one frame or less than a frame over a stream, it's not probably going to be beneficial. You want to do it in the application layer then.
Yeah, because I'm trying to kind of marry this with what Peter presented, and I think if you're talking frame by frame, if you're talking about letting the application do frame by frame processing, for instance, then it becomes, you know, it becomes difficult for the application to buffer that many frames to make FEC effective in that case. And then and we're back, and so we're back to actually saying, no, we don't want to give the application that capability. We want to push it down for the implementation where buffer management is probably better handled.
Right. So there are three solutions for the FEC, right? One, the encoded frames that come out from the encoder have like FEC already there, and you don't worry about it, or you push that responsibility down to the transport, which would then have FEC, or you could have all three. You could bring your own FEC, have something coming in from redundancy from the encoder figuring out, and quick also. Like, I'm not suggesting all three, but what I'm suggesting right now is that maybe we need to figure out, let's get the ball moving and figure out FEC and congestion control and some of these things as we go down that path. Because if you want to give the application developers the flexibility, maybe all three choices are valid, and it might depend on like configuring your encoder to like say like, hey, I don't know about FEC. You just figure out the FEC at your end. Give me FEC, or I'm smart enough, I'm going to figure out the FEC myself, or let the transport figure out the FEC. And I think all three options may be valid.
I want to add, even if you leave it to the application, like if encoder gives you FEC, you still may want Quick to be aware of it, because you want to hack maybe frames that were recovered, or you don't want to merge FEC frames with content frames.
Right, and I think that there's a lot of when we talk about the statistics, both from the receiver side and getting statistics from the local side, those are the points of presence that I would be really interested in, to be able to like get these statistics and maybe not have Quick the transport have to figure these things out. Mm-hmm. Maybe there can be input coming from the application to tell the receive side that I've already, do not send these NACs for these quick things.
Yep, I completely agree. Mm-hmm.
So seeing that we're now at the usual backlog compared to planned time, I think it's time to wrap up this segment. I noted the two pieces of decision. One is on the WebRTC Quick API, we have a decision to be taken to the list on whether to adopt the document. And I hear the working group encouraging the proponents to turn the streams page slideware into a proposal so that we can actually take a position on adopting it or not. Apart from this, are there any decisions that need to be taken based on this segment? And thank you for the very interesting information. Hearing silence. Let's go back to review. So let me see if I can make this the right slide. Yeah. The sleepy guy is always getting to me. And now it's showing a new slide. That's strange. So wrap up the next steps. One thing we've heard loud and clear over the last few days is that people want WebRTC 1.0 to be finished, as in stop wiggling. And they want implementations to be interoperable, which means testing enough to make sure that they are. So that's a high-level bit. We also heard a number of things that indicate that people are wanting to use real-time media things in web browsers that are not within the current WebRTC 1.0 specs, and that they are going to do so no matter what we say about it. So if we want to have it standardized within the WebRTC working group, then we'd better get on with it. But get the WebRTC 1.0 done with high priority. So that's a hard combination to match up, but we'll have to do it somehow. The chairs will go on off and contemplate. So concrete things of decisions that we decided. We had a number of issues that were looked at and said, okay, we decide, bang. Combined origins, gone. Media functions, secure context, bang. Screen share. Full screen is info, not normative. The spec for constraints will be merged. We will not allow URL white and blacklist in screen share. We have a proposal for removing the surface type constraints. And we have a removal of the must not statement on changing sources. And we have consensus, surprisingly, to move get display media to media devices, which is therefore secure context. We have not made a decision on exclude on audio. There was the proposal that we might say that in this context, echo cancellation on means exactly that. But this is not a decision. Please go on discussing. WebRTC PC, we had a consensus decision, now verified and duly recorded, to stop saying anything about track.id mapping into STP, or out of STP for that matter. We had consensus rename transport.transport to transport.icetransport. And that direction is set when SRD set remote description answer is done. Clarifications to codec parameters accepted. Set codec preferences remains on transceiver. And Orpheus has promised to write the tests. Use order and answer as preference. Don't make life complicated. And make codec payload type read-only. Selected candidate pair needs further work. So these are non-decisions. We didn't take a decision on them. Nobody can claim we did. And we need to discuss codec payload type in that transceiver. Henrik and Bernard promised especially to discuss that. Now, if you see anything in this quick review that you think is the wrong recorded wrongly, please speak up.
Not entirely sure, but making codec payload type read-only, I think that depends on other decisions that require further discussion. But maybe, if you add a maybe there.
Maybe it's not a decision. Maybe the decision was this, and you just have to go fight for it. Become maybe.
I can add a maybe reconsider.
Sounds good.
What was use order in answers preference again?
It was that when you do a set remote description with an answer, and the answer has a list of payload types, which is the recipient's preference, then unless the user explicitly says use this codec, it will use the first on the list. Make it simple. Let us see. Slide back in %. So, testing. We will have a regular web platform test review meeting. Chairs, editors, UN, and I didn't catch the name. Kartik. Have volunteered. Now this was interesting that so if I now do forward and then back, then it should have changed. No, it didn't. So we will create a per spec web platform test directory so that we get everything linked up to the spec that it's specified in. We will aim for a simulcast, a virtual interim sorting out simulcast things in January. And we will aim for, that doesn't mean hit, but it means that we will aim for a hackathon at the ITF in March, Prague. Use cases are adopted as a working group document. On WebRTC ICE, we have said that we can change ICE candidate pair to an interface. Yeah, that reflects back into PC. So that will cause a pull request on PC based on the decision in the that came out of the discussion on ICE. That's a nice thing about having an adopted working group document, that this is a working group decision. Peter will consult with the CDN folks on whether forking is needed or not, or how forking should work when it's needed. And we will use network information to represent network information instead of defining our own type. That may cause heartburn down the road if the WebRTC ICE spec gets to be considered for candidate recommendation before the network information spec gets some kind of formal status. We will sync up on that. On SVC, we will adopt this document now. That's to be verified on the mailing list. On audio, we have a consultation with Web Audio Working Group needed. We have a consultation needed with the machine learning community group about what they need on audio. We did not make a decision to adopt my draft for a non-web audio API. It's from the feedback, it seems that it's very possible we'll just drop it. On streams, new APIs need to be streams-based. I recorded a non-decision on either adopt stream messages or need more info. I can't tell exactly what I intended by that. We'll have to go back to the minutes. But we definitely have a decision that we need advice from the stream folks, Dominic at Co, about how to best to get processing off the main thread. Peter, I believe that you volunteered to do that.
I don't remember volunteering, but I suppose I could try. Is there anyone else who would be better than me?
I suspect not. Especially after you have made such a bad job of not of ducking.
All right, I'll take it.
Okay. On data channel, we will add an on-closing event. Stats.
Sorry, on the previous 2 slides on a data channel, was there any decision on WebRTC data channel extension spec? You said it was unclear. I guess that's either downstream messages or need more info.
Yeah,
should I keep working on that document?
Keep working on that document.
All right.
I think it's one of those cases where, yeah, we have a grand vision of the bright shining streams palace in the sky, and we have a number of paths that might lead there, but all of them seem to include this step. So why not just take it? So keep working on it, but we don't have a decision on it yet. Stats. Stun server stats, the proposal is acceptable. Let's merge it. Add .mid to senders and receivers. We don't add a transceiver object at the moment. We add stream identifiers to senders, and we move the stream objects to obsolete. Jan-Ivar will write a PR to say exactly which stats end when. Hey, I escaped. And we do not remove track stats at this time, but note that it's not mandatory to implement. And if the WebRTC PC spec says that it's mandatory, we'll fix that.
I think the spec right now says they're only on the sender. So we would need to add language if we want it to be on the receiver.
Yeah. But yeah. Yeah, we might have. We expose IP addresses only if and as seen in an ad candidate. That is, if it's a MDNS camouflage name address, then we show the MDNS camouflage, and if it's an IP address, we show the IP address, and if we didn't get it through ad candidate, we don't show it. We'll copy the size stats to outbound RTP and remove them from sender. We will not remove them from track. We will discuss the details on when the pull request is ready for discussion. And we had no consensus on leaving network type in the spec or taking it out. So that is for further discussion. On workers, among the options that UN presented, we'd like to pursue the option 2, that data channel is in workers, based on the idea that WebRTC ICE is available and can be used to establish the data channel. That will get a number of APIs exposed to workers, but not media. UN offers to specify this when there's developer interest, so any developer who has interest will then pester UN. Somehow it's gone into hiding.
It's probably worth noting here when you say workers that you mean driven by the desire to have them work in service workers, which is different than desire to have them work off the main thread.
Yeah, this is about workers, which is JavaScript context that exists independently from the major.
But there are web workers and then there are service workers, and I believe this is in the context of wanting to work in service workers. So, for example, if somebody said, "Hey, we'll do it with worklets instead," it wouldn't cover this because this is specifically about service workers.
This is specifically about workers. I didn't hear people say that they would wanted it in web workers or in service workers. One or the other.
So one thing that makes service workers different from workers and makes it a particular motivation for option 2 is that in service worker, you need to manage network changes and the lifetime and so on.
Exactly.
Which in simple workers, you could just keep on the main thread. but not in the case of service workers. So I think that's the reason for the distinction.
Exactly.
So even though it's not only for workers, service worker adds an additional constraint, which makes that option more appealing than some of the other options that are also appealing in other contexts.
Exactly.
So at least service workers, and then it's no risk. But is service workers a proper subset of workers?
If it works for service workers, it should work for other workers. But if it works for any worker, if it works for web workers, it doesn't necessarily work for service workers. So that's why putting service workers here is making it a little more clear about what we're trying to achieve.
Yep. So data channels and yep. So that's.
I just think if you changed workers on the second line there into service workers, then that would be slightly better.
Yep. And we'll just remember from our learning that this also means that workers are covered, other workers are covered. And this work has lower priority than WebRTC 1.0 and WebRTC ICE, since it depends on WebRTC ICE. That's kind of logical. End-to-end encryption. The working group will adopt the end-to-end use case where we trust the application but not the relay. With some doubt in Stockholm on which of these we would adopt, but we'll verify this on the list because we're slightly iffy. The web working group is still considering the generic access to encoded data use case, whether that's adopted or not. And the working group recommends basing APIs on transform streams. So we're starting to fall in love with streams. So based on the quick bring your own transport presentation, the working group will ask the list if we should adopt the WebRTC quick API document. I noted a clear majority in the room indicating that they wish to so adopt, and a couple of strong voices saying we should not. And the working group encourages Peter to turn the streams-based slideware into a proposal that can actually be evaluated for adoption. That was all the decisions I noted that we made so far. Does anyone remember deciding anything else? No. So, this is the end of the slideware. So we now have a little time to say, okay, how do we go from here in such a way that we actually make good progress towards our next goal? And what is that next goal? I see kind of two groups of goals which are somewhat orthogonal. One is pushing the specs of WebRTC 1.0 to the zero bugs state, and which includes getting the specs fixed, getting the tests done, getting the implementations up to speed, which are kind of like three branches of that. We have, as a working group, we don't have any control over implementers, but we do have implementers present that have strong input into what their companies do. The other thrust is that we would like to make sure that if and when real-time functions on the web are considered for standardization by other working groups or by this working group, the expertise in this community is considered. That might be take the form of us adopting proposals for processing within this working group, or it might take the proposal, the approach of just making sure we know about each other. As the second screen working group presentations here was a clear example of. So what advice do people have for the chairs as what should we do next?
Harold, this is Bernard. I think we clearly have some process problems relating to WPT. So that seemed to me to be the most seriously broken thing. It doesn't really have to do with the working group, and it's an example of something not that the working group that we haven't paid enough attention to. So I think that's clearly something I think that particularly if we eventually want to get to test before commit, we need to fix.
Yeah, I agree with that, and I think that's that would progress. And my input would be that the sooner we can finish with 1.0, the sooner we can focus fully on the next step.
And also, I would say with respect to finishing 1.0, one thing I've noticed is that one reason things don't get implemented is that there are problems in the spec, and developers look at it and say, I don't understand this, so I can't write code. So I would encourage developers to start filing bugs, even if they might not really be bugs or just we haven't explained things well enough. Just go and file them. Don't just sit there twiddling your thumbs or be confused. Don't be embarrassed. Just go file issues.
We also have a number of things that, well, nobody's complained about them missing, or very few people have complained about them missing. So that might be sometimes be an indication of things that need to be taken out and shot.
I guess the developers here mean the browser developers, because the application developers, when they see some interface or API not implemented, they just skip through. They don't read the specs at that point. So there have been several situations where we've looked at it and we said, none of the browsers actually do anything here, so move on, nothing to look at it, right? So we don't know if there are bugs really in the text because we haven't really looked at some parts of it. But one of the things that came up and one of the things that seems to be like a big thing that we need to take care of is simulcast. And the fact that it cannot be taken out of the spec into its own means that there is work to be done here apart from the testing and fixing the bugs. And I don't know if we've really put in significant time to think about simulcast.
Well, I think we have, in the extent that it's already, the code is already in browsers. I think the problem is that I think there are some, as we've seen from just a few of the questions that Henrik raised, there are some serious problems with the spec. And I think we need to get into them more because this is a case where the code is already there. So we're just talking about some JavaScript, and clearly something's wrong with what we've got in the spec if they can't, you know.
The thing with currently deployed code is, of course, that the browsers have all been hacked to do this in non-standard manners because it was quicker than implementing what's in the spec, among other things because the spec needed fixing. So we have a pattern of non-standard behavior.
Yeah. Also, we have, I mean, to be blunt about it, it's not at all clear to me that the RID stuff in the spec makes sense or that people are going to implement it. But
that would be a serious. If that one isn't right, then we have a serious problem on our hands.
Yeah, I'll just note that nobody's implemented RID so far, so just putting it out there.
We're depending on SSRC signaling, which has its own problems.
Yeah, and I think when we're talking about 1.0, we're talking about WebRTC PC becoming a CR or PR, and I think stats go with it, fortunately. And I think there's a fair amount of work to be done there as well, especially we've put the simulcast discussion for stats as well. Delayed it just because we haven't seen much implemented. And whatever we've seen is poorly implemented. So
about RID, Firefox has a very early implementation of set parameters that accepts RID, but does not, as I learned, signal it in the RTP header extension. So we'll open a bug on that.
Yeah, I mean, as another example, nobody emits the mid header extension either, or uses it to route packets. So.
So I think those are, from the discussion, I think simulcast seems to be like the big red heading sitting.
To clarify, in Chrome with Unified Plan, we do implement the mid header extension, sending and demuxing.
Are you planning to support RID header extensions in Unified Plan?
I am not sure.
Nobody seems sure.
We will certainly, speaking with my Chrome hat on, we will certainly try to figure out whether we're planning to do that or not. Real soon now. Personally, I think we should.
So back to my implementation timeline question. So we have an issue with specking simulcast, but given all that set of issues at the spec level, I can only imagine it's 10 times worse at the implementation level. So I mean, do we really believe we can achieve that in the upcoming few months ahead of us?
Well, I will say this, having looked at it in detail, the problem is when you have this many open questions in front of a developer, they often wonder whether it's appropriate to ship something until there's enough consensus to tell them what to do. They don't want to be in a situation where they ship a bunch of stuff that ends up not being in other browsers. So that kind of thing does delay implementations eventually.
I guess the other question is, should we put more effort into thinking about removing simulcast into its own spec? Because we can't be in a situation where we can't get it implemented, nor can we get it out of the spec into its own spec.
Well, it won't help to put it in its own spec if we basically don't know what should be in that own spec. I mean, I think that's basically the problem here. Right? We're going to have enough implementations at some point where, you know, people are going to come in with positions about what should be in or out, and I don't think we're far from that time. But I think the main thing is getting all the problems on the table so we know even what we're debating, which I'm not sure we know yet.
I mean, like, if we can pull out everything from that says simulcast or is needed for simulcast into its own spec by creating partials on those interfaces or dictionary.
I think we tried that, right?
We tried that. It just became even more confusing, and it would probably delay implementation even further.
So we tried that, and the result was less readable. It was less readable, but that does not mean that we could not do it, right? It's just that it feels less right. And at the end of the day, what we would like for WebRTC 1 or plus would be a full spec with everything consistent in it. But maybe in the short term, it's still fine to say, let's split it. It will be not great for some for 1 or 2 years, and then we will remerge it in 2 years from now.
So, I mean, I don't want to over-promote anything, but as some of you may know, the advisory board has started looking into evergreen standards model inspired by the living standard. And my understanding that probably inspired by what is being proposed in terms of the collaboration with the WebRTC on HTML and other documents, is that you could mark some subset of a specification as non-normative, basically, so that you could escape the implementation rule for the specific part of the spec that's basically not baked enough. So there are a lot of details and considerations and so on. I guess my high-level question is whether that is something worth investigating at all for this, or that's a distraction.
I think overall we're all looking for a way to like get 1.0 to a point where we can say it's 1.0, and if simulcast is going to take more time, and if you think that it's part of the 1.0 activity, because if it's part of the 1.0 activity, but if it's part of the PC spec, then we want to like drive all our efforts in that direction. But if it's not the case, then there are other things that we want to do, the SVC stuff and the I stuff, and so I would. If we know that simulcast is going to take time, then either we say that this is not the focus at the moment, and we can focus somewhere else. But saying that it's not focus and not aligning our efforts to reach that target seems.
I mean, I think what you say, very good point. One way of thinking of this is the relative priorities of simulcast and the other new shine.
Yeah, I mean, there's a whole bunch of applications that either will settle on proprietary functionality and just ignore the spec if it doesn't get done. So again, it would be a case of the working group either finishing simulcast or abandoning it. I don't think there's really any point in letting it sit in a separate spec and not get finished, because it'll just, the whole market will go proprietary at that point and ignore the working group.
Isn't that what's already happened in some sense, that there are?
Yeah, it's already happened, but we're moving to unified plans, so we have an opportunity, if the working group can finish this spec, to actually get a standard implemented. But if it doesn't, then you might as well just, that'll mean that essentially the future of WebRTC 1 will be all proprietary. Everything advanced should just be done outside the W3C, and we'll be done with it.
Yeah, I think that's a good point.
So I guess the question is, what is the next step? As in, we've just in 15 minutes only come back to the same position we were at the beginning of this discussion.
Well, I just think that we needed to have a push to get all the issues out, because I don't think we know what they are yet.
So Dom, you were saying that with the current spec, if we go evergreen now, we would be able to do some things, or is it like post-PR that we would be able to do things?
Again, I don't want to overpromise, because this is pushing some of the existing boundaries, but we could look into pushing the existing boundaries for 1.0 if, again, we think that's a value. Again, I don't want us to spin our wheels into process considerations. The process should be our tool rather than our goal. But if we believe that this helps us clear some of our plates, and I'm happy to at least investigate it with directors.
Yeah, I would tend to not. So we should consider, we have a list of issues. We should try to say, hey, for developers, this is the top priority, so let's try to fix it first. If it means simulcast is at the end, then it's at the end. If it means, on the contrary, that it's the first thing to do, then we should shoot for it. I don't have, it's difficult for me to actually judge on that, but if we have some information there, that might be very helpful to prioritize simulcast, but also all of the WebRTC 1.0 issues.
So what? Just to clarify, what does simulcast 100% done look like? Is it? Are we worried about? Yeah. It sounds like one approach would be, as long as we have tests that we need to be able to track when we're done.
Yeah, I think it means having tests, but it also means being very clear about everything that affects the behavior of a simulcast implementation.
Yeah, and then you need to implement. You need to have some prototypes, at least 2 prototypes by probably this summer, I guess. So
Well, we have the prototypes we have shipping implementations, so it's more than just prototypes. I mean, the question is, can the shipping implementation actually move to the spec?
yeah, that's what I mean. We hopefully by January or March we'll have a stable spec, and then do we have enough throughput to say that these prototypes will be able to go up to the spec and then show that the spec is interoperable.
So just for my own clarification, to interoperability between browsers, are we covering that in our tests, or are we mostly covering API?
API.
Well, API, but with things like Simulcast Playground, you could actually test in interop.
Right.
Yeah, so we don't have we don't have the implementations. We also don't have the tests to test those implementations when we get them.
Dr. Alex from Cosmo. We do have some tests for simulcast. They're not updated, so they're checking a little bit of the current state and not the spec. But we have in place all the system to actually spawn an SFU part of the test and test against an SFU and so on and so forth. I'm ready to spend as many resources as needed to make that happen. We got a lot of people that came to us and say they need simulcast to happen, to the point where we actually implemented support for H.264 simulcast and provided the patch to the browser vendors. So it is important for a lot of people, and they're not going to drop it even if we put it out of the spec. So we're ready to push you and shoulder some of the testing effort. If you tell us exactly what should be tested, we're going to write the test for you and make the system available.
I guess one question I have is, I know it's a little bit disconcerting for developers because they don't want to ship something that might not be right. But is there a way to have like an extended run in Canary or in Firefox nightly, and so that at least we can begin the test writing process a little bit earlier? Even a month or two would help.
So I'm sorry, Bernard, I didn't understand the question. Are you asking if we can test on Canary and Beta?
Yeah, I'm just wondering if at some point we are told, hey, this is close enough so that you can start writing the tests for Canary or Nightly. It doesn't have to be finished. It's just enough. We just need enough of an implementation so that we can start figuring out what we don't know.
We have had an implementation for 4 or 5 months already that we're testing against Canary to help Google in the effort of porting Unified Plan and Transceiver. And
Unified Plan and Canary doesn't support simulcast, does it?
Well, we had different kind of version to. It's failing to, right? But at least you see when it's turning from red to green, and that's the definition of done, right? And I think that's what Jib was asking for. Or do I know when it's okay? So we wrote the test first, and then the guys. So it's running today against Firefox and everything. So if that's not what you want, tell us what you want.
No, that sounds good. But just to clarify, it sounded like you mentioned that some of the tests right now test the status quo. So if they show us if status quo is considered green, maybe switch the test so that it's considered red or yellow or something. So that green means spec.
Right.
So the idea is the most difficult to be infrastructure. Have the browser that run a given test. Okay. The most difficult part was to set up the infrastructure. Still, WPT cannot do that directly. To be able to ask any question, and we reached that. And so the question we ask would be outdated for the goal you have today. But now the only thing you have to do is to ask the next question. The rest of the system, test system, can be reused. So, and that's pretty fast.
Okay, so testing seems to be a solvable problem based on the input here, as long as we know that the APIs are clearly defined for what we need to test. So, jumping up a level, it sounds like the chairs will have to stick their heads together and think about what's at the top of priority list and get around to whipping it getting simulcast under control, as Bernard says, get us moved up the mountain is pretty important. And getting the rest of the spec cannot be ignored. I mean, we need to reach bug zero. So with that, I think it's time to wrap up the meeting. And we are planning a simulcast focused virtual intro in January. Some of us will meet in Bangkok in a few weeks. Some of us will not. And the list is open and the organizer is organizing. And the editors will meet as usual. So let's go forward and let's get this show on the road. Thank you all for coming. Thanks to everyone who subscribed, and thanks to Dom for making a sound system that actually worked. And we'll see you all soon again.
The credit for the sound system should go to the systems teams. I was just a messenger, so.
Okay, I'm stopping recording.